You guys agree we cannot FOIL this thing. Okay? So we've got to grab the 2x and multiply it by a what? Negative 4x plus 3y minus 8. So write down 2x times negative 4x plus 3y minus 8. How many people got to this step? Let's go. And then you distributed the negative 7. So minus 7 times negative 4x plus 3y minus 8. If you got this one wrong, pay close attention when I distribute. What is 2x times negative 4x? Sebastian?
Negative 8x to the second.
Excellent. Negative 8x squared. What is 2x times 3y? 1?
It would be plus 6xy.
Plus 6xy. We Gucci? What is 2x times negative 8? German? Negative 16x. What is negative 7 times negative 4x? Andres? Positive 28x. What is negative 7 times 3y? Kristen? Negative 21y. And negative 7 times negative 8, we can all answer that? Positive 56. All right. Now, there's only two things that we can combine. What are they? Kristen?
The 2x's, the negative 16 and the positive 28.
Excellent. The negative 16x and the positive 28x. When we add negative 16x and 28x, what do we get? 12x. So it's negative 8x squared plus 6xy plus 12x minus 21y plus 56. Trick question, peeps. Is this in standard form? Look at it closely. How many people think it's in standard form? Raise your hands. How many people think it is not in standard form? Okay, this is in standard form. Now let's talk about why. What is the degree of negative 8x squared? 2. What's the degree of 6xy? 2. What's the degree of 12x?
1.
What's the degree of negative 21y?
1.
And the degree of 56? 0. So check out, guys, okay? This is very important. Make sure you're paying attention. You can flip the 6xy and the 8x squared, okay? Those can be in a different order. If they have the same degree, it doesn't matter which one comes first, right? But what you can't flip is any of the ones that have 1 degree versus 2 degrees. Does that make sense? So it has to go 2, 2, 1, 1, 0. Make sense? Any questions on that? Special, okay? These are special products of polynomials, okay? The first one that we're going to learn about is when we square a binomial, okay? So highlight a plus b squared. So we're going to have a binomial, in other words, 2 terms, and then we're going to square it. And how I want us to visualize this is I want us to draw a little picture to the right of this rectangle. Do you guys see that rectangle on your page? Okay, draw another one. Right next to it, like this. Draw the little sleeves down the side. And label this x plus 5, and this one x plus 5. Now, let's imagine, right, that we were finding the area of this box, right? And this segment right here along the left side is x. And this segment along the top is x. What would this square, what would its area be? X times x, right? What's x times x? X to the second power. Put that inside the box. Now, move on to the one on the right. This length is 5. This length is x. What would the area of this box be? 5x. Now, move to this bottom side. This one is x, right? This one is 5. So what's the area of this box? 5x as well. And then what's the area of this box right in the corner? 25, because it's 5 times 5. So watch. What you're going to notice is that whenever you are squaring a binomial, these two terms that are your like terms are going to be the same. Okay? Now, I'm going to show you guys the FOIL method, right? How we know how to do it, foiling. And then I'm going to show you the shortcut. Okay? So bear with me in the beginning. If you see the pattern, hold on to it. Okay? And then we'll talk about it at the end. Okay? So go down to the first two examples. Okay? Example A. Kristen. Yes. Okay. So we've got 3x plus 4 squared. I'm going to start by walking over a common mistake. Write this in there. This does not equal 9x squared plus 16. Circle this and cross it out. How did I get to this answer? Sophia?
You multiply the 2 with the 3, but it's not going to get multiplied because it's an exponent, so it'll just be 3x squared.
Correct. I distributed this squared to both terms. Okay? We cannot do that. Okay? When we can do that is if we had 3xy and we raised it to the 4th power. Then you can distribute the 4. Okay? What's different about this scenario, guys? You're adding. Okay? Do you see how there's two terms here? You cannot distribute your exponent if you have more than one term. So watch. Is 3x plus 4 is now our base. Agreed?
Yeah.
And if we square something, what do we do with it? Multiply it by itself. So write this out. It should be 3x plus 4 times what? 3x plus 4. Do you guys see the difference there? Now, it's two binomials, right? What do we do when we have two binomials? You FOIL it. So let's FOIL it. What's 3x times 3x? 9x squared. What's 3x times 4? Plus 12x. What's 4 times 3x? Plus 12x. And what's 4 times 4? 16. You guys with me? All right, what can I combine? The 12x's. So I should get, what's my final answer?
9x to the power 2, 24x, 16.
Plus 16. Okay, this is the way that we know how to do already, right? This is foiling, okay? So we're going to hold off on the shortcut. I'll show you it in a second. Do we have to use the shortcut? No, okay? So let's do the second one. Again, let's FOIL it. So 5x minus 2y, we're squaring it. So we're going to write it twice as a product. So we're going to write 5x minus 2y times what? 5x minus 2y. You guys with me here?
Yeah.
Because squaring something just means multiply by itself, right? Someone walk me through foiling it. Allie, go.
5x times 5x is 25x. And then 5x times negative 2y is negative 10xy. Then it's negative 2y times 5x, which is negative 10y. No, negative 10xy.
Yep.
And then negative 2y times negative 2y is positive 4y squared.
Very good. One thing is missing though. Allie, I want you to find it.
The square on the 25.
Good. It should be 25x squared. Are we all good with this? Are we done?
No.
What can we do, Diego? Okay. How do I do that?
You move the 4y squared main from the 25x.
Ah, so these all have a degree of what? 2, right? So does it matter the order? No. But there is something we can do. Diego, do you see it?
Oh wait, the negative 10x.
There you go. There's 2 of them, right?
Yeah.
What do I do?
You subtract it, it's going to be negative 20x.
Good. So 25x squared minus 20xy plus 4y squared. Cool beans? All right, you guys ready for the shortcut? Okay. Before we talk about the... Preston, what's up? When Kristen comes back. Yeah, Andres?
Shouldn't the 4y squared be in front of the negative 20?
So it could, okay? But technically, this has a degree of what? 2. This has a degree of 2. This is a degree of 2. So in this case, does order matter? No, because they all have the same degree. So you could have listed it any way that you want. Okay? All right. I'm going to blow your minds. Okay? So the shortcut. I need you guys to write in. This is our shortcut. Okay? We had 3x plus 4 squared, right? What you do is you take the first term, 3x, go ahead and highlight it. And you're going to write, okay, 3x squared. You're going to square it. Then you're going to take the second term, which is what? Plus 4. And you're also going to square it. So you're going to write over here on the end, 4 squared. And then your middle term is going to be 2, so plus 2 times the first term, which was 3x, times the second term, which was 4. Okay, hold on. So, let's walk through it again. The 3x, right? You bring it down, it becomes squared. That's your first term. You guys with me? Your second term, which is the 4, right? You put it at the end, and what do we do to it? Square it, okay? Then you take both of them, multiply them by each other, and also multiply them by 2. So watch. I'll show you. Watch. So what's 3x squared? 9x to the second. What's 2 times 3x times 4? Well, what's 2 times 3? Times 4? 24x. And then what's 4 times 4? Did we get the same answer?
I find that harder.
Yeah, I find that harder.
It's not good.
Okay.
I don't understand. It's like a back road.
Okay. Now, Allie brought up a very good question. Allie said, give me 1 second, Storm. Allie said, where is this 2 coming from? Now, scroll back up. How many 12x's did we have when we did this with FOIL? 2 of them. Whenever you square a binomial, that middle term, there's going to be 2 of them, and they're going to be the exact same. So you just multiply it by 2.
So right now, do we have to do the shortcut?
No, you don't have to do the shortcut. Do we ever have to use the shortcut? No, you can FOIL the snot out of everything, okay? Yes?
I'm saying like now, like
Yeah, I'm going to do all of these using the shortcut, okay? But you can FOIL them, okay? But for now, I want you writing both methods. Got it? Because we need notes for today, all right? Go to the second one, okay? What's my first term, people? 5x. So write it down below. Write 5x, and what are we going to do with 5x? Square it. What's the second term, peeps?
negative 2y.
Negative 2y. So you're going to write down negative 2y at the end, and what am I doing with it? Square it. In the middle, you're going to put a plus. What number goes in the middle? 2. And then the first term was what? 5x. What was the second term? Negative 2y. What's 5x times 5x? 25x to the second. And then what's 2 times 5?
10.
What's 10 times negative 2?
Negative 20.
Negative 20xy. And then what's negative 2y squared?
Negative 2y squared. Oh, that's...
Storm, what's up?
I like the FOIL method better.
When Preston comes back. If this is more complicated, do you have to use it? Okay, the answer to C is posted. Check. In your groups, I need to make sure that everyone got it right. Double check in your groups that C, everyone got it right. Ask your neighbor. We take x and we square it. So we should have written x squared My second term is 7. So at the end, I'm going to have 7 squared. In the middle, I'm going to have 2 times x times 7. You with me? So now I've got x squared plus 2 times 7 is 14x. And then 7 squared is 49. If you FOILed it, you should have gotten x squared plus 7x plus 7x plus 49. The answer to D. Dun, 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 dun. What? Yeah, because I know the shortcut. So this one is 49x squared minus 42x plus 9. Two negatives, when you add them together, make a positive? Yeah. All right, let's go over this one. So 7x is my first term. So I write 7x and then I square it. Agreed? My second term is -3. So put that at the end and square it. What goes in the middle? 2 times 7x times -3. You guys with me? All right. What's 7x times 7x? 49x squared plus 2 times 7x times -3. Well, 2 times 7 is 14, right? Yeah. 14 times 3 gives me -42x. And then plus 9.
Why didn't you do this one? I think I did this one. I got. Is that this step? Like, what do you do here, though?
You add them together.
What do you?
For E, you should have taken 4x and squared it. You should have taken -y and squared it. Then you should have had in the middle 2 times 4x and times -y. You guys with me? Yeah. What's 4x squared? 16x squared. Plus 2 times 4 gives me 8, but it has to be negative. So -8xy. And then plus, what's -y squared? Y squared. Yeah, you should have erased that plus sign. It should have just had -8. Okay? F is going to be 3m. You're going to square it. You're going to take n and you're going to square it. And then you're going to have in the middle 2 times 3m times n. So we're going to have 9m squared plus 6mn and then plus n squared. This next one is called a sum and a difference pattern, okay? So the first shortcut was for what? When we were doing what? It was like 3x plus 4 squared, right? So we had the same thing times itself. There's a difference between these two binomials. What's the difference here, guys? One's adding and one's subtracting. So we call this the sum and difference pattern, okay? Sum and difference pattern. Why is it called sum and difference? One's adding and one's subtracting. Does that make sense, guys? Okay. Now, before, do you guys remember when we FOILed and we got those two middle terms and they were the exact same? When you have the sum and difference pattern, they're not going to be the exact same. What's different about these two? Javonsky? They're opposite signs. So what happens when you have -2x plus x? They cancel out. So you're going to have no middle term. Yeah, so you can still FOIL for these, but there is a shortcut, okay? So the first two that we're going to do, we're actually going to FOIL them. Then afterwards, we're going to apply the shortcut, okay? All right, so for the first two. Oops.
But it only works for certain ones.
Correct. Why can we apply the sum and difference here?
Because there's an addition and a subtraction.
They're the same exact thing, but one's addition and one's subtraction, right? Now, I want you guys to write a common mistake over here on the left, okay? Can I apply, if I had t plus 5 and t minus 3, can I apply sum and difference here? No. Why not?
Because the numbers are different.
The numbers are different. Do you guys see that? You can't apply it here because it has to be the exact same. The 5 and the 3 don't match up. Do you guys see that? See how the 5 and the 5 match up? So we're going to FOIL this one just to see it this way, but then I'm going to show you the shortcut, okay? So you're going to take t and multiply it by t. What's t times t?
T to the second power.
T to the second power. What comes next?
T negative 5. Which
Good.
is negative 5t.
Yup. What comes next?
And then positive
And then
t5.
T.
5 and t. So plus 5t
And then
And
negative
then negative 25.
and then negative 25. Hey, what do you guys notice about those middle two terms? They're the same but different signs, right? What's negative 5t plus 5t? 0. So we're going to get t squared minus 25.
And that's it.
So check out the shortcut. When you have a sum and difference, watch what we have to do. Label this the shortcut. What was my first term? T. Square it. What was my second term? 5. Square it. And throw a minus sign in between them. What's t squared? T squared. What's 5 squared?
Negative 25.
Say what? Yes? No? Maybe. All right, let's check it out. The next one. Did we all get that down? We're Gucci? Okay, the next one. Hey, we're going to FOIL this one still before we use the shortcut, okay? So FOIL it. Take 3x, multiply it by? 3x. What's 3x times 3x? 9x squared. What is 3x times y? Excuse me, negative y.
3x.
I mean negative 3xy.
Negative 3xy. Y times
3x is
3xy.
3xy.
And then negative y to the
Negative y.
Negative y to the second power. What do you guys notice?
There's
You
one,
can the negative 3x
cancel.
y and yeah.
Yep,
And
they're
then
going to cancel.
3xy.
you should
So,
get 9x to the
We're going to get 9x squared minus y squared. So let's do the shortcut. What was my first term?
3x.
3x. So write 3x and then square it.
That's shortcut.
Mm-hmm. This is the shortcut. What was my second term? Y. Throw a minus sign in between them and then take y and square it. What's 3x times 3x?
9x to the second power.
What's y times y?
Y to the second power.
Did we get the same thing?
Yeah. The first one is more work. What's easier?
Do I care, as your teacher, which method you use? No. Okay? Is this helpful, though, in a lot of situations? Absolutely. Kristen, what's up?
Where did you get the x y, negative 3?
Okay, so I took 3x and I multiplied it by negative y, right?
Oh, that's
So that's where I got the negative 3xy, and then I took positive y and multiplied it by 3x. Good question. Gabby? I don't know if I can do that. I can write over it, though. I know, but for mine, I'm not in Notability, guys. This is a weird app. All right, try C and D. Go. Is that better? Yeah. All right, check your answer to C. Should have been x squared minus a hundo. D, you should have gotten 4, oops, writing with a highlighter. 4x squared minus 1.
Bro, I always forget to put
E,
x plus 2x.
the answer to E should have been x squared, oops.
To negative 9y to
x squared minus 9y squared.
Okay.
Speakers, at this time, please.
Guys, what was the same about all of these problems? Why could we apply this shortcut? Sophia?
Because they have different adding and subtracting.
It was addition and subtraction, right? But were the terms the same? Yes. That is what you look for first, right? So the first shortcut is when we were squaring something, right? It was the exact same binomial times the exact same binomial. This is almost the same binomial except for what Sophia said. One is adding and one is subtracting, okay? All right, what I need you guys to do next. F is the exact same example as E. I don't know why I double duplicated, okay? I need you guys to cross out example 3. Cross out the special product patterns to find each product. And then go down to the very last slide. This is like a little summary of the entire lesson, okay? When you square a binomial, or when you square a binomial and it's the difference, and then the sum and difference pattern, okay? And then your exit ticket is, I want you guys to think about this. The product of two binomials is not always a trinomial. You need to write down the one scenario when you multiply two binomials and you do not get a trinomial. Go. All right, did any group get it? What is the scenario when we will not get a trinomial when we multiply two binomials? Lawrence?
If they're different parts, they cancel out.
I love that. You're super close. Sophia?
I said, well, we're using the same difference pattern.
Excellent. So exactly what Lawrence said. When your middle terms are different signs and they cancel out, and otherwise known as the sum and difference, and difference pattern. So instead of a trinomial, when we do the sum and difference pattern, what do we get? A binomial. Do you see how we're missing that middle term? This is also considered a binomial.